Interfaces are like contracts that cannot be breached. In this chapter, we're going to talk about interfaces, default methods, sealed classes, and many more.
In this video, we're going to talk about interfaces. If you ask somebody what is an interface, they're going to say an interface is a collection of abstract methods and constants, which is right, but how does it make sense? And if you ask them what is the purpose of interfaces, then they're going to say the purpose of interfaces is to solve the problem of multiple inheritance, which is also true, but that's not it. Interfaces are not introduced to solve the problem of multiple inheritance. There's a different purpose to it. We're going to take a look at how it solves the problem of multiple inheritance, but let us try to understand the actual intent of introducing the interfaces. Take a look at this. Let's say there are three software companies, S1, S2, and S3, and they all specialize in providing the source code for robots. Let's assume they have class files, say R1, R2, and R3. Inside these class files, they write the source code for the robot. So it can have methods like move, and inside this method it will have some instructions to instruct the robot to move. Similarly, there can be stop method, etc. And here this can have walk method and halt method, and here it can have again walk and pause, so on and so forth. If you observe, the task performed by all these methods, stop, halt, and pause, is essentially to stop the robot. The goal of this method is ultimately the same, is to stop the robot. Keeping that in mind, let's assume that you have a robot, and since you're not such a big techie, you can't write a code similar to this by yourself. All you know is basics of Java. You know how to create an object of a class and make use of the methods inside that class. Nothing more than that. So since your knowledge on writing the code is pretty limited, what you're going to do is you're going to purchase the code from company S1, essentially the class file, the bytecode of the source code, and what you're going to do is you're going to create an object of this class R1, a new R1, and make use of all the methods inside it, object.move and object.stop, etc. Now we have a very serious problem here. Can you guess what it is? Let's assume that you realized that the code provided by company S2 is more relevant for your purpose, and you thought the code provided by company S2 is more efficient and is performing the task faster than the source code provided by company S1. So you just wanted to switch to this source code. So what you're going to do is, instead of R1, you're going to say R2, which is a class file from this company. But how do we make changes in here? For example, instead of the method move, you're going to have to use the method walk. Instead of the method stop, you're going to have to use the method halt. So for this purpose, you need to go look at the documentation and try to understand what they're doing. You need to try to understand what their source code is doing to be able to make changes to your code. And we're just talking about a single class file, but in reality it would be an entire project. It's pretty time consuming and a messy process to make changes everywhere. Now in future, let's say you wanted to move to some other vendor, maybe S3 company, then you will end up doing the same. It's a pretty painstaking process. How do we get rid of this problem? The solution is interfaces. You can think of an interface as an abstract class, except the difference is interfaces will not have methods with behavior. Of course, with the introduction of default methods in Java 1.8, you can have some behavior written, we'll talk about it at later point of time. But for now, assume that an interface can only have abstract methods and constants. So the syntax of defining an interface would be something like this. We're going to take a look at the example in our next video, but just for the sake of this example, let's see the syntax. For abstract class, you're going to have to say class abstract class name, and you will have the signatures of the method. But coming to interface, instead of class, you're going to say interface, and you get rid of this word abstract because it is implicitly assumed that it is abstract. Let's call this I1. I stands for interface, and all you're going to have is signatures of these methods, and you don't have to explicitly mark these as abstract because the Java compiler does that implicitly. Whatever the methods you have in here will be marked as abstract methods, and whatever the variable that you have in here, say int x equals 10 or whatever, by default compiler will assume them to be of final static. You can't have a variable that is not of final static. Essentially, you're just going to have only the constants in an interface. But coming back to our example, how does an interface solve the problem? All these companies, S1, S2, S3, they're going to have a small meeting and they're going to discuss about their problems. They found out that customers are finding it difficult to move to a different vendor. The guy from S1 says, there's a customer who is interested in taking our code, but he's not taking our code because there's a lot of tasks involved in making changes. Same is the problem with other companies as well. So all these three companies will come to an agreement that whatever the class files that we write will have the same signature for their methods. And the way of standardizing that process is through an interface. So all these three companies will discuss and figure out an interface for a typical robot. It will have all the method signatures like maybe walk, run, navigate, whatever. Whatever are the typical behavior of a robot, they will decide and put it inside this interface. And all these class files in here are going to implement this interface. So instead of saying extends, let's call this interface I1. So instead of saying extends I1, we're going to use the keyword called implements. Again, we're going to take a look at this example in our next video. Implement I1, and everybody is going to do the same. Implement I1, and by doing so, all these class files are forced. They're forced to give some behavior for all the methods inside that interface. Now, how is this solving the problem of the customer? Let me explain you. The customer, I mean you in this example, instead of saying R2, he's going to create a reference type of this interface, I1. So instead of R2, he's going to say I1. And this reference type of interface will point to, say, this class object, R2. Now by doing so, he can only access the methods that are defined inside this interface. He can't access the method move anymore. He's going to access the method walk, whatever is there in the interface. Now in future, if you decide to move to a different vendor, all you have to do is to change the object to which this reference type is pointing to, say R3, something like this. Now you don't have to make changes anywhere else in the code. The reason is, since everybody inherited or implemented this interface and you use that interface as the reference type, the methods are going to remain same for all the vendors. Isn't that amazing? So from your perspective, by using an interface, you have the flexibility to switch to different vendor as and when required. At the same time, there is improvement in the maintainability of the code and the time it takes to make changes to your code. Also, if you're switching to a different vendor, you don't need to know the internals of their code, and you don't need to understand what their code is doing. For example, Without the interfaces, instead of stop method, you'll have to figure out what your new vendor is using and make changes here. But with the interfaces, no matter which vendor you use, you're going to have the same method. So essentially, all these vendors will expose this interface and make it public to everyone. And people like you will look at this interface. They don't look at source code. So this is kind of like an abstraction mechanism, which is also one of the major features of object-oriented programming language. And also these vendors will keep this source code proprietary. They don't want to expose it and make it public. So, but still they can just expose only the limited details like the method signatures by exposing the interface. On the other hand, the benefits that the companies like S1, S2, S3 will have is again the flexibility that they're offering to their customers to switch to a different vendor. In a way, all these companies are forced to implement this interface. The reason is only if the company implements this interface will the customers like you prefer their code. And also another benefit is, let's say there is no interface, and if they make changes to this method definition, then whoever or their clients, they all end up getting compilation errors because now the signature changed. But with interfaces, there is no scope for change. It's going to remain the same thing forever. In fact, if you try to make changes to the signature of this method move, let's say, then you're going to have a compilation error. So there is no room for mistakes as well. So that's all what an interface is. We're going to take a look at some of the interesting examples going forward. Stay tuned. Let's take a quick example of interface. For that, we're going to create a new project, which is obviously a Java project. Let's name this project as interface project. As a good naming convention, we always start our project name with a capital letter, and every subsequent words will also start with a capital letter. Let's click finish. Inside the project, we have a default package. It's not encouraged that we use the default package, so we're going to create a new package, which is interface package, whatever the name that you want to give. But make sure you follow a naming convention of camel case, wherein the first letter starts with a lowercase and all subsequent words will start with an uppercase. Click finish. Right click on this package and we're going to be creating an interface. Let's call this interface animal and click finish. There you have it. We have an interface. The next thing that we're going to do is right click on the project and create a new class. This class, I'm going to call it land animals. Basically the animals that live on land. Let's click finish. So we got land animals, and inside this animal interface I'm going to define a method which is going to be a breed, something of that sort. Let's do Ctrl Shift F to give the proper indentation to the code. Now what we're going to do is we're going to use the keyword implements animal. Now by doing so, we are forced to give the implementation for all the methods inside this interface, and that's why we have this error in here. The type land animals must implement the inherited abstract method animal breed. You can just resolve the error by clicking this. The Eclipse IDE will help us in doing so, and whatever that you want to do, you can do it over here. System.out.println. You're gonna say something, maybe breathing, whatever. And besides this, you can also have your own other methods. This is fairly a very simple example of using an interface. Let's take a look at another example. Let's consider something that falls in the subcategory of land animals. Let's say a frog. I'm going to copy this class. I select this class, I'll do Control C, select the project, and I'll do Control V. This will copy the class. Of course, we need to give a different name, and that's why we got this prompt. I'm going to name this frog. And inside this class, I'm not going to implement animal. What I'm going to do is I'm going to change a little code in here. I'm going to make this class an interface. And of course, interface does not have an implementation, so we're going to have to get rid of this, and we're going to provide some kind of an abstract method. What is that one thing that every land animal does? Let's say jump. Just for the sake of example, I don't know if an elephant can jump, but just for the sake of example, let's assume so. Let's save the file. Can you guess why we have an error here? That's because when we use the keyword implement, we should provide the implementation for all the abstract methods. But in this case, this is an interface. An interface cannot provide implementation for its parent interface. So instead of using the keyword implements, you're going to have to use extends keyword. Just as class extends a class, an interface extends an interface. But every class can implement an interface. The reason is only if it is a class can it provide the implementation for all the abstract methods of an interface. So the keyword makes sense. Now if you observe, a frog is kind of a land animal, and at the same time a land animal is a kind of an animal. Our hierarchy is in right shape. Now what I'm going to do is I'm going to do implement land animal, and by doing so, not only should we provide the implementation for the jump method, but also for all the abstract methods inside the grandparent interface, which is in this case is animal. Hover your mouse over this error and click on this. There you have it. Breathing and jumping. This brings me to talk about one of the problems with the multiple inheritance or hybrid inheritance. Let's go to whiteboard and I'll try to explain it. So what is a multiple inheritance? Take a look at this example. We have an animal class, we have a land animal and a water animal, which will both inherit the properties of an animal. Now let's assume we have an animal which is neither completely water animal nor a land animal, which are called amphibians. A good example of an amphibian would be a frog. Now this will have the properties of both land animal and water animal. Now if you think there's one thing in common, one thing is common between a land animal and a water animal, which would be breathing. A water animal breathes in the water and a land animal will breathe in the air. But the frog is both. If we were to write a Java program, then we would have this method inside both these classes. And let's assume that Java supports multiple inheritance, just for the sake of example. By the way, what is multiple inheritance here? This part of this is multiple inheritance, wherein a class will try to extend more than one class. So in here, the frog class extends land animal and water animal. If you do it programmatically, we get a compile time error here. The reason is Java doesn't support multiple inheritance, and we'll see why. Let's say we're supporting multiple inheritance, and if I create an object of this class frog, so frog object equals new frog, and if I do object dot breathe, Is it going to call the breathe method of a land animal or water animal? There's a confusion, right? This is the ambiguity. JVM cannot figure out which method to call at the runtime. So to avoid the confusion, Java designers decided to eliminate the multiple inheritance altogether. So in your program, you would get an error in this statement. You can't extend more than one class. This is also sometimes referred as the diamond problem, looking at this pattern, which looks like a diamond. Hope that makes sense. Now, people say that interfaces solve this problem of multiple inheritance, which is wrong. With interfaces, we eliminated the problem itself. We didn't solve the problem. So let's assume we have animal interface, a land animal interface, and a water animal interface. And let's say we have a frog class. A frog class can implement both land animal and water animal interface. And multiple inheritance with interfaces is possible in Java. Also, by the way, these two will implement the animal class. Now, if we create an object of frog and do object.breathe, you will not get a conflict. That's very obvious because there is no implementation or behavior written in these classes. The behavior is defined or written inside the frog class. There are no two behaviors. It's just one behavior provided by the frog class itself. So there is no scope for ambiguity. Let's take a look at this example in our workbench. Let's go back. So let's create another class which could be a water animal. I'll just do Control C and Control V. And instead of land animal, I'm going to be doing water animals. Say breathe. Let's have the same method declared inside the land animals as well. And in here, since we no longer have this method, we get an error. Let's save the file. You can implement both water animal and land animals interface by using comma, like so. Water. I'll do Control space to complete my statement. Let's save the file. And let's create a new class in here, which would be our main method, just to be able to execute this method. Let's right click, click new, and class interface example. I'm going to be needing this public static void main method. Let's click finish. What I'm going to do, as you would pretty much can expect, frog object, new frog object dot breathe. This is going to call the breathe method inside the frog, which is pretty obvious. You can also have the reference type as one of these two categories, land animals or water animals. Let's do it. Land animals object2 equals new frog. Let's go to end of the statement and copy this statement and paste it over here, and you see no difference in the output. Let's run the program. There you go. These are the bare minimum examples of interfaces. We haven't yet walked into the mainstream yet. When we talk about collection framework, we're going to be exclusively talking about some of the major features introduced in Java 1.8. They're going to be very interesting topics, and we'll get there pretty soon. But for now, let's just keep focused and stay tuned. See you in my next video. In this video, we're going to be talking about default methods. Going back to our robot example, let's say we have this interface with all these abstract methods, walk navigate, talk, etc. The problem with interfaces is it doesn't move along with the trend. For example, let's say there is a new technology out there, say a fingerprint sensor, and I want every of my client to provide implementation to use that technology. When I say client, I'm talking about the people who implemented this interface, my interface. But there is a problem. Let's say I have introduced a new method, new abstract method in here, which would be, say, sense, fingerprint, something of that sort. Now everybody who is implementing my interface are forced to provide implementation. This is not a good thing for my reputation. Nobody would like to be forced. At the same time, if I let go this technology, then somebody else is going to define a new interface and he's going to define such standards which will use the latest technology. And slowly over time, people will start migrating to a different implementation. And that's not good either. So thinking about all this, Java 8 introduces default methods. The actual reason of using default methods can be understood when we cover the concept of collections. It makes more sense there. But for now, this example should suffice. But let's move on. So what is the solution in here? The solution is obviously default methods. So now what is a default method? So far we haven't been able to provide implementation, or we haven't been able to provide behavior inside an interface. I mean, all these methods are abstract. We cannot have a curly brace and provide all the instructions. But from Java 8, it is possible that you can provide the implementation. But you need to make sure you will mark that method using a keyword called default. For example, in this case, we have introduced this new method, which is sense fingerprint. So I'll just simply get rid of this semicolon in here, and I would put a curly brace and provide some instructions to do something with the fingerprint sensor technology. Let's assume so. Now all the people who are implementing my interface, they don't have to provide implementation for this method because I have already given the default behavior. I'm using the technology. But in case if these guys decide to provide implementation, they can always override the behavior of this method. So when we create an object of one of these classes, let's call this class C1, and when we create an object of it, C1 object equals new C1 whatnot. So object dot sense fingerprint is going to call the method which is overridden. In case if you don't provide any implementation, this is going to result in calling the default implementation. So that way there is backward compatibility. You can introduce new methods. At the same time, you don't have to worry about people who already implemented your interface. But this has introduced a new problem. Actually, it has brought back the old problem we had with multiple inheritance. Remember the diamond problem with the multiple inheritance? We have eliminated that problem using interfaces, but now we introduce that problem back again by introducing default methods. Let's say we have interface A and B, and we have C, which is implementing A and B. Now let's assume that both A and B interfaces is having a method, say XYZ, and both these interfaces are providing default behavior in here. Now when we have an object of C, and if we do object.xyz, which method is it going to call? Confusion, right? So Java 8 has provided some solution for this as well. Let's go to our workbench and try to understand. First, let's quickly take a look at an example of default method. In here, we already implemented these two interfaces, land animals and water animals. What I'm going to do is I'm going to introduce a new method in here. say void maybe make noise, something of that sort. Now, did you see the problem that I was talking about? We are now forced to make changes to provide implementation for this method. But with Java 8, you can just convert that semicolon into curly braces and do whatever you want to do here. There's a shortcut to quickly type system.out.println. It's just type in sysout and then control space. It's just sysout and then control space. It's to control space. It should work. Maybe it's because of this error it is not working. Let's get rid of this. And as we know, we need to mark this as default method by using the keyword default. Now this should work. Sysout and then control space. It's a shortcut, keep a note of it. And making noise, something of that sort. Maybe we'll get rid of the capital letter in here. Alright, now we no longer are forced to provide the implementation. And in here, I get rid of this. I do object dot, instead of breathe, I'm going to say make noise and run the program. There you have it. Now let's try to override that method. So all I'm going to do is copy this and paste this in here. You can always use this annotation, override, and make sure you make this public. Let's run the program. By the way, let's make some changes in here. Make noise from frog, something like that. Let's run the program. There you have it. The method is overridden. Now let's talk about the diamond problem, or the problem we had with the multiple inheritance. Let's get rid of this. Let's introduce the same method here as well. And we're going to get rid of this keyword. Make this default. Make noise from water. Let's save the file. Okay. See, now we have an error here. What does that say? Duplicate default methods named make noise with the parameters blah blah blah. So it's just basically suggesting us that there is a conflict. So the way we deal with the conflict is by overriding. We'll override, and in here, instead of giving your own instructions, you will tell Java which default method to call. And the syntax for that is you're going to use the name of the interface. For example, I'm going to be using this name dot super dot make noise. Now if you run this method, it's going to call the make noise method inside the land animals. Alright, and let's say you gave the water animals interface in here, then it's going to call the water animal default method. So that's how we deal with the conflict. That's it on the default methods. But again, the real reason of introducing default methods can be understood in better fashion when we talk about collections. See you in my next video. In our previous video, we talked about default methods, or also known as defender methods. What I should have also mentioned is that interfaces support static methods starting from Java 1.8. Actually, Java designers should have introduced static methods much before, but they thought that it would violate the rule of interface where an interface cannot have implementation. But in Java 8, with the introduction of default methods, anyway they have violated the rule of interface a little bit by allowing us to provide the default implementation. And since we did so, there's nothing wrong in allowing static methods as well. So the way you define a static method inside an interface is same as a static method inside a class. For example, you're going to do static void something of that sort, and you can have anything that you want to have in here. And in order to access this method, you can always use the interface name. So in our example, let's comment this out. I did Control-Shift/, I guess it's a / to comment out the selected part. And in here, I'm just going to call that method. Let's save the file and run the program. Well and good. Another thing to note is you cannot override the static method, even if you have the same signature. For example, I'm just going to copy the same method in here. Now this looks as though this method got overridden, but in reality it's not. For example, if I use this annotation override in here, it's going to throw a compile time error saying the method static method of type frog must override or implement a super type method. Basically what this means is the compiler did not find this method in the interface that is of not static. So we get rid of this, can't be overridden. Now looking at this interface, this looks as though this is an abstract class, right? An abstract class can have abstract method and also can have static methods. So what is the real difference? There seems to be no big difference between an interface and an abstract class. But there is a difference. Unlike an abstract class, since it's a class, it has some kind of a state. You can always have variables defined on top. Whereas in an interface, you cannot have a state. You can only have constant in an interface, which are public, static, and final. And since there is no state, there is no purpose of having a constructor. So interfaces cannot have a constructor. There's no meaning of it. And obviously, since there is no constructor, you cannot create an object of an interface. You can only have it as a reference type, but you can never create an object, or you can never create an instance of an interface. Hope that makes sense.
Let's talk about sealed classes in Java. Assume that you have an animal class or an interface, and then you also have dog, cat, and lizard classes which want to inherit animal class or an interface. Now assume that you only want dog and cat classes to inherit the properties and behavior of animal class, but not the lizard. Or a more realistic example would be, assume that you have a card class or an interface, and then you only want, or you would only expect either debit card or credit card classes to be able to extend the behavior of card class, but not the Amazon card class. You don't expect Amazon card to be using the card services or to extend the behavior of a card class. Well, before sealed classes, you have to work around this, somehow make some tweaks with the constructor to be able to accomplish this task. However, Java didn't have this support out of box until sealed classes were introduced. With sealed classes, you'd be able to put restriction as to what are all the classes that can extend the behavior of the card class in this case. So here's the syntax to either create a sealed interface or a sealed class. You have the public access specifier, and then you will use a sealed keyword followed by either interface or a class. The name of the class or the interface, in this case it's card, and then you're going to use the keyword permits, and you're going to list down all the classes that you want to permit to extend the behavior of the card class or implement the card interface. In this case, it's debit card and credit card. And if some other class or an interface tries to extend or implement the card interface, we're going to have a compile time error. Next, we're going to see all this in action. Okay, what we have here is a very clean workspace with one file which is currently doing nothing. We're going to fill this up pretty soon. But let us first go ahead and create a class or an interface. Let's create an interface. Let's call it card interface. And let us also create a couple of classes. I'm going to say class debit card implements the card interface. And then similarly, we're going to have credit card as well. And let us also create one for Amazon card. Now there's no concept of sealed at this point in time, but we'll get there in a minute. Let us go to our main file and then try to create an instance of the Amazon card. So we're going to have the reference type as card, which is an interface. Amazon card. And we're just simply going to print a message. Just to make sure everything is working good. So the fact that we're able to see this message means that we didn't had any runtime issues whatsoever. Now let us go ahead and implement the concept of sealed interface or a class. When I say sealed classes, I could mean a sealed interface or a sealed class depending on the context. So I'm going to make this a sealed interface. And the moment I make that change, we see compile time errors. Let's take a look at what it says. Well, it says the class debit card with a sealed direct superclass or a sealed direct super interface card should be declared either final, sealed, or non-sealed. I'll explain what this means a bit later, but for now, let us make all these classes as final. And this would solve part of the problem. And then we've got another compile time error that says the type debit card that implements a sealed interface card should be a permitted subtype of card. Guess what? We have to use the permits keyword and explicitly mention what are all the classes we actually want to permit to extend or implement the card interface. So we want to allow debit card as well as the credit card, but not the Amazon card, and that's why we have this error. Cannot use Amazon card, and same applies here too. So this is going to be debit card or a credit card. And now if you run the program, everything works as expected. Now, why we need to use the keyword final here? Why is the compiler complaining about it? Give it a thought. I'll explain it in a while. Okay, I really hope that you've tried to figure out why these classes has to be final. Well, the reason for that is if these classes are not final, then we're essentially destroying the very purpose of sealed classes altogether. How? For example, we could have Amazon card class, which might extend debit card, and we already know that debit card is already extending or implementing the interface card. What that translates to is that we have the Amazon card as a subchild of the card interface. This is clearly against the principles of having a sealed interface or a class. We don't want Amazon card to be child of the card interface. However, if this class is not final, we are allowing it to happen. And that's why the classes that inherit a sealed class or an interface have to be declared final, or they can also be sealed, or they can also be non-sealed. Let me explain you what I mean. For example, I can change this to a sealed class and it is allowed. However, we have a compile time error. Let's take a look at what it says. Well, what this is essentially saying is that we have a sealed class, but I didn't have any of the child classes that are inheriting the sealed class. Otherwise, what's the point of having a sealed class? Only if you have certain set of child classes which can inherit the sealed class does it make sense to have a sealed class. So we do have to specify what are all the classes we want to permit by using the permits keyword, and maybe we want to have Visa debit card as the child class of debit card. Now, of course, we have a compile time error because we don't have this class. So we have to create one. And because of the fact that this is a sealed class, its child class has to be declared final. So at some point in the entire hierarchy, it has to end with a final class. So this could be Visa debit card, which extends the debit card class. Got the name wrong. And there you have it. We also have another keyword called non-sealed class. For example, I can make this non-sealed class, and it is allowed. So with this, as you might have guessed, we could have, say, Amazon card, for instance. Let me copy this. And that can extend credit card, and we do not have any compile time errors. What this means is we're explicitly letting know the Java compiler know that we actually know what we're doing. We know the consequences and we're fully aware of what can go wrong, but we want this to happen. So there could be those corner cases which I personally cannot think of why you need to use a non-sealed class, but there could be such corner cases where you might want to allow this to happen. So you have non-sealed class, which is like saying the compiler, yes, I know that I'm destroying the purpose of sealed classes. However, this is an exception case and I want to proceed this way. And the compiler doesn't complain anymore.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.